Right, there we go. Right, so here, I hope you can all see my screen. My name's Andrew Hayward. I'm a Senior Software Engineer here at Transoft. I've been here for more years than I care to mention, and I've been working mainly on the App Integrate product, which is a services-orientated architecture for legacy. It's very much geared at opening up legacy systems to modern technologies, although what modern technologies has changed over time. So it's an established product with thousands of users, runs on Windows, Unix and OS 400. It's comparatively lightweight compared to a lot of alternatives. It's scalable and fast, and as I mentioned, it's geared towards legacy systems, so we can integrate with existing legacy code in RPG, BASIC, COBOL, probably something else I've forgotten there. We can also access SQL data sources and via another product of ours, non-relational sources such as, again, COBOL, CI/SAM data, and other non-structured data sources. And if we don't have access to the code, then we can go in through the screens through a variety of terminal emulators, such as VT100, Toast 70, and the like. On the client side, we have multiple connectors. So we have obviously COM was far and away the most popular for a while, and then obviously Java and .NET became popular, and now increasingly it's web-based connection through JSON and SOAP. So here, for example, is the typical kind of legacy application you would want to integrate with. So I have a simple terminal application. I can look up customers. Oops. Try this again. Can't remember how to use it. Yeah. So here I can generate a list of customers, for example. I can enter an order. Oops, except I don't have the authority to do that with this user. So I can look up a customer account and so on and so forth. And we have this demo written in various languages, but this one in particular is in a Micro Focus COBOL. So moving on, we have a quick overview of the App Integrate architecture. So at the center we have the component broker, which is a thin server which runs on Unix, Windows or OS 400. It's configured with a service definition language, which is very much geared towards legacy systems. And on the left-hand side we have our consumer technologies. On the right-hand side we have our provider technologies, language, screen and data. And one thing I should mention is that these aren't kind of mutually exclusive. There are situations when people want to be able to access, for example, C# services through, for example, COBOL, and that can be accommodated. And similarly, some people need to integrate disparate legacy systems. So, for example, a COBOL point of sale system may need to access an RPG warehousing system or something like that, and that again is possible. But today I'm going to be concentrating on the iOS and COBOL aspects of the product. For development, we have a development suite, Transoft Development Suite, and we use that to create our SDL file, our service description, and generate proxy, which is our term for client codes, and wrapper codes on the server side. So I shall Oops, I shall go into the development suite. I'll show you the development suite here. If I can't, there we go. Okay, so as I mentioned before, the development suite is all based around this SDL, service definition language or service description language, which has been designed with legacy systems in mind. So if I give you an example service, we have a service called General Search here, and we can look at it in the tree view here. If I bring up this service here, we can see it has properties. Oops, not that interested in that bit. We're more interested in this, properties here. Yeah, we have, it accepts 4 input parameters. As we can see, we have 4 input parameters, and they're all geared towards, the data types are all geared towards legacy systems. For example, this maximum number required is specified as a number rather than, say, an integer or a float, for example. So it's all kind of fixed with decimals, characters, and we have some support for wide characters as well. Okay. And in this instance, this service returns a result set, so an arbitrary length result set. So we have these values returned in the result sets, and the other types of services may just return simple output parameters. Now, one other facet of the service description language is we can also include canned test data. So in this instance, we can say if you receive these values when the server is being run in test mode, if I receive these values, the server will return these result sets. So that gives us an option to test the client application in isolation from the back end. So you could have your client developers working on their client code without the back end being completed at this stage. Okay, so once we've completed our SDL file, the next step is to generate code from it. So we have proxies, which is our client-side code, and wrappers, which is our server-side code. So up here we can see in our SDL we have numerous client and server-side options. So in this instance we're using ObjectiveC down there, and on our server side we're using Micro Focus COBOL. Now all this code is generated from a custom macro, so it's quite easily customizable to an organization's own standards or to a particular language variant that we might not have come across. Anyway, so we generate our proxies and wrappers, and here in our client proxies today we're interested in our ObjectiveC, and on the server side we're interested in our COBOL. And most of this stuff we can safely ignore, but I will look at the search COBOL. So as you can see, on our COBOL side we get a load of boilerplate code here, and this links in with our associated app integrate library. So for our general search we just take a bunch of inputs, and then we'll plug in our own code here to do the processing, and then return a bunch of outputs repeatedly to generate the result set. And that looks something like this in our completed code. This is generated with an older version of the wrappers actually, so it doesn't have so many comments in it. But generally the idea, this is quite simple search code where our code just forms a file read and returns it all in the result set here. So depending on the complexity of your COBOL or your business logic, it may or may not be a straightforward job, but in this case this is quite a simple one which just performs a file lookup. From the client's point of view, a service is a service is a service, whatever it's written in. So you could swap it out for one that's just a SQL statement. You could swap it out for another language, or just another variant of COBOL, and the client wouldn't need any adjustment. For our iOS development side of things, we generate ObjectiveC here. The header file includes apple.comments so that we can see what the input parameters are and result sets are. And we have a module file here. Whoops. And again, this just calls the app integrate server through the JSON connector to receive the service results. So in this instance, I have an app integrate server running on Linux. Is it this one here? Yes, yeah, this machine here. So we can see this one's just, as app integrate receives connections, I've got the logging on, so I can see where those connections are made. So I will bring that up in a moment. I'll get back to that in a minute. And app integrate comes with a series of management tools. We integrate with various server monitoring software, but we also have a very simple monitor here, which I'll just show you, so we can see what is currently running on a particular server. So I can see there's actually no active components on this until I actually start running them, but we can see what service is available. So here's our search service that we're going to be looking at today, our general search service. Let's see how many requests have been made and what sort of time it takes to process those requests. So moving on to the iOS app, I'll bring up our Mac here. So here I have an application I've just built from the basic templates that Apple gives you in Xcode. And I've pulled in the generated code here, our furniture application that I generated from the STL. Also, we have some boilerplate code that also gets generated when I build the when I generate my proxies. And I've tied that into the master view controller here, so I can give you an idea of what I have done to tie that in. Firstly, once the initial master view is brought up, we have a viewDidLoad method here, and once that executes, we create an instance of our furniture application. Then we call the general search service with the parameters as a dictionary. Now we can look up those parameters in the Xcode help, because that uses the Apple.doc tool to generate this help file. So here we have general search, execute this. And being a web request, being an HTTP request, it runs asynchronously. So it fires off this service, and then as it completes, this callback gets called to set up the internal object list with the results of our request, and then reload the table view, which is the main grid, the main list of items in the in this particular template. And then the final change that I had to make to take the starting template and turn it into an app that calls App Integrate. Here we have our cell where we generate a cell from a template, and I'll set the text to values from one of the rows that we retrieved earlier in our App Integrate call. So if I run this with a bit of luck, we'll get a list of customers. So yeah, so in this instance we've made an HTTP request to App Integrate. I should see that on my I should see that on one of these terminals here. No, oh, it's this one, isn't it? I should see it on here. So, oh, sorry, I've got the logging way up high. I saw that request here in the logs saying it's called the general search service there. I can now see on my monitoring tool, if I refresh this, I've made another request to general search, and that the component, which is equivalent to a binary, the component of that provides that service has one active instance. Now the App Integrate broker manages those instances. You can specify minimum and maximum active instances, so you can have a bunch of server instances ready for a large number of requests, or you can reduce those to save on memory or some such, but it gives you that management capability. And we can also sort of check on the amount of time that it's taken to execute service and such like. So that was a simple request response service. If I can return now to our SDL, if I minimize that, bring up our SDL. Up here we have something called a context, and that is our way of maintaining state. In App Integrate, there's no one-to-one relationship between the client side, our iOS app, and the server side, which is our COBOL component. To maintain state, we use something called a context, which is roughly analogous to a HTTP session. In this instance, I have a context that stores current order details, and that context gets passed to the server-side components that have specified their interest in it. So if I go down to our order entry SDL, we can say we use this this context here. So every time the client makes a request for one of these order services, the component gets passed the details from these context entries. So coming back to our Mac session, I'll stop that and bring up a different project which shows you the furniture demo. So here I'm making the same sort of calls, but I'm also passing a session ID. So it's a bit like making a call to a web application where we store a session in a cookie, but in this instance we're storing the session ID in the app. So here I will run this particular example where this calls multiple components. So here I've got the login. I'm making use of the login service, and if I can create a new order here, sorry, you can see that I'm not an UI designer. So we're running basically the same list of customers, and here we're maintaining the state. So I'm calling this, for example, add order line the add order line service. So I'll just give you an idea of what services I've called. So I called the new order, and then I called a subsequent add order line, but in that add line I only specified what product code I wanted to add and what quantity I wanted to order. I didn't bother with any other stuff because the server already has those details, and that context details can be passed between components. So here we had a separate component for the logon, so a separate COBOL binary performed the logon action, and then subsequently the order entry component has those logon details. So that's how app integrate maintains state. So we can continue adding lines here, blah blah blah, and I've got a lot of logging in my example app showing what services are being called here, so I can see what requests are being made to my app integrate services. But if I bring that back again, so we have these order lines, then finally we can finish and commit those details, which calls the service which I defined earlier somewhere, wherever it is. There we go. So we confirm that particular order. Okay, so right, just moving on our slideshow. So that was our quick introduction to app integrate development. Give you an idea about the kind of deployment scenario here. This is an old slide actually, which says HTML, but obviously that would apply for any JSON connector. We're typically using a web server as a proxy to the app integrate server, but there's no real restriction on what web server you can use. Anything that supports reverse proxying, so Apache, IIS, all fairly straightforward to set up to forward a subset of calls onto the app integrate server. So that's typically how we would deploy, and obviously the web server gives us secure sockets and such like. So just to recap our development process, first, the thing about the app integrate development process is we always define the interface first. We use our SDL to define the components and services and our test data as well, so we can test our front end in isolation to the back end. We create our components through the wrapper code, or indeed through SQL statements, or through scripted access to terminal emulators, but obviously I've shown you the COBOL stuff today. And we generate our mobile app generating ObjectiveC proxy code, and then we can weave that into our application. Okay, and obviously ObjectiveC is not the only solution. Obviously, I've shown in a previous webinar using HTML5, and we're working on Android libraries as well. Okay, so our next webinar. Thank you all. Oh, our next webinar is new features in FlexGen. I don't know if you have any requests, any questions surrounding app integrates. If you'd like to send me any questions. I don't know. Do I have to enable anything? Does anybody have any questions? Well, I probably should have pre-prepared some, but I'm afraid I haven't received anything. So, well, thank you everybody for coming on this webinar. And so we have our next webinar is in a fortnight, in 2 weeks' time, and I think we'll be getting some more out every 2 weeks after that. So, thanks very much for attending, and hope to hear from you soon. Okay.